trying to trying
Yeah.
to do kind of not fully open book, but some open book papers.
Mhm.
Um, and I'll mark it, and if there's any specific topic that I'm struggling on, I'll go back through and I'll review it.
Mhm. All right, all right.
Like
Yeah,
that.
this is the best practice nowadays. When your exams are approaching, the very best thing to do is to practice as many past papers as
Yeah,
possible. And after that, just check on your mistakes and then see what did you do wrong. And
yeah,
you know what? Let me give you one more tip. For example, if you have attempted a question or a paper, and after
yeah,
doing the paper, when you checked on from the mark scheme, you got some questions wrong. Now,
yeah,
definitely, you are going to look at the mark scheme to know which questions are wrong. After knowing about the wrong question, the very first thing to do is try to understand why did you do wrong, what was
yeah,
the missing concept in it, and then write it down in some register or
yeah,
in a notebook, right? So you need to write specifically what point you didn't know or what point
yeah,
you got wrong, right? In this way, when you will be done, you need to write all the wrong concepts, right? Let's
yeah,
suppose you knew about that concept, but when you were doing the question you forgot about it. Still you need to write, you when you will check it, or you will when you will check it, and you'll see, you'll say, oh god, I knew about it but I forgot. No, don't forget to write it down in your notebook. Do write it
yeah,
down that I have to remember these things. And let's suppose there were 40, 50 MCQs, or 40 MCQs, and then some structured questions. Whatever you do wrong, honesty, write down the concept which was wrong in your register or notebook, and towards the end of the paper you will have a comprehensive list of those concepts
yeah,
which you need to reinforce.
yeah,
All right.
yeah. I
So this
agree.
is the tip I give to my student. And you know what? If, the question you have got correct, that is something which is correct. There is no need to change the concept. There is no need to reinforce it. You need to work on those things which were incorrect. So
Yeah,
that's the main thing, right?
yeah,
All right.
yeah.
So Maya, should we continue the paper we were doing?
Yes.
All right.
Miss Salim,
Yeah.
I wanted to ask, our lesson next Wednesday.
Mm-hmm.
I was gonna ask today, but then I think it's too late. But can can we go through every reaction in organic, from
Okay.
from alkanes to the carbonyl groups and the amino acids, etc. Just just a brief summary of what they react with, what they make, and the reagents needed.
Yeah, sure. Actually,
Thank
I'm going to do it in two steps. The very first thing is a comprehensive summary of each and every topic, and
you.
because I do get these types of question in CIE board, and definitely, as I told you earlier, that CIE board is very close to OCR board. All
Yeah,
right. So the main thing is, in our board we get a question in which there is an interconversion of one organic compound into another organic compound, right? This
yeah,
is called as schematic diagram. They give 4, 5 compounds with arrows and write reaction
yes,
one,
yes,
two, three,
exactly.
four. Yeah,
Yeah,
on
they
it.
do the same thing.
Yeah. And then they ask about the reagents, conditions, and everything. So that is the best thing, because students separately, what I have observed in students, separately, if I'll ask them to tell me about the reactions of alkanes, they are going to tell me flawlessly. But when the conversion comes, they get confused. So I'm
Yeah,
going to divide the lecture in two parts. One is to quickly go through all the reactions of each and every class of the organic compounds, and after
yeah,
that, how to convert one compound into another.
yeah. So just questions.
Yeah, just
Okay. Yeah,
questions. And the questions would be related to the organic chemistry only, right?
yeah.
So in
Just
this way, you will be
program.
able to revise it. One
Yeah,
thing more, sorry. Mahia, I have given concept maps to my students, right? For CIE board. That is writing down I'll let me share my screen with you. So I'll write it down. Uh,
yeah,
All right. Hmm, just a minute. Yes, Mahia.
Yeah.
Yeah, towards the end of it, I will write. For example, let me see if I get any question in it as well. Like this. All right. This is very important. The question you see on the screen. Yes.
Yeah.
Or this is, I think, related to physical chemistry. So we are
Yeah.
going to get the paper about organic chemistry in the next
Yeah.
lesson.
Paper
However, yeah.
2 is organic.
Yeah. So, yeah, paper two is organic. Yes. So the other thing is, for example, if we have benzene, so writing benzene in the center and then taking out the arrows and writing like this. Even instead of writing benzene, let's write like this, benzene.
Um,
All right.
yeah.
Then how to get this benzene? How to get this benzene? Oh, sorry. Um, this nitrobenzene, right? So in this way
Yeah.
you can do the, or for example, how to
Oh, wow.
get.
This is so much better than writing it out.
Yes.
All these
And
all
what,
these words, they just
yeah,
jumble
yeah,
into
and
one. Yeah,
yes,
yeah,
and
sorry.
you need to write down the reagents. For example, I divide the reaction in 7 steps for my students. Now they need to write down the reagents and conditions here and some
Yeah.
observation here. So in this way, instead of revising it from the notes, they only revise it from the concept map. So let's
Yeah,
suppose if they,
it's so much easier.
yes,
Yeah.
yes. So if there are, let's suppose, 7 topics, for example, for us, we have benzene, we have methyl benzene, we have phenols, we have amines, we have what else? Disonium chloride compound.
Wow, I've never heard of that.
Yeah, we have acyl chloride. So all these are. So, for example, I think I'm missing on one, two more organic compounds, but still one, two, three, four, five, six. So instead of doing it in the form of paragraphs or the notes, my students, they have seven, or I think in total we have 9 organic compounds. So they have 9 concept maps. So what do? They simply revise from those concept maps, and they find it really very easy, because otherwise if you will write it in the form of notes, it will make almost a booklet. But if you are
Yeah.
going to do it in the form of concept maps, it would be far easier to comprehend, to reinforce, to remember.
Yeah.
Yeah. So you can also apply this method as well. Or I'll help you. Let me go through your syllabus, and then I can, because you know that, as I told you earlier, that 80% or 70% of in terms of OCR, 100% of OCR is included in CAIE. But there are some topics which are in CAIE but not in OCR. Yeah. So what I'll do, I'll try to filter them out and I'll make the concept map so you can revise from those concept maps.
Thank you very much, Miss Shubnam. Thank you.
No problem. My pleasure. My pleasure. So don't you worry about that. And this is the first thing you need to do. That is in
Yeah.
terms of the notes, that you need to make the concept maps. And the second part would be the conversion from one compound to another compound.
Yeah.
Yeah. So don't you worry. You will. I'll try to make them, and then I'll keep on posting them on WhatsApp group. What you can do is you can take a printout of them and start
Yeah.
revising.
Yes.
And you know what my students tell? They say that when we are doing the paper in the examination room, the whole picture of the concept map comes in our mind, and then we
Mhm.
do accordingly. That towards the top right side, we wrote methyl benzene, towards bottom, we wrote nitrobenzene, and the
Yeah.
conditions, the reagents, everything comes in their mind.
Yeah.
Yeah.
No, I think it's a very effective way. It's a
Yeah.
lot more helpful than paragraphs of words.
Yes, yes, yes. So I'll, don't you worry. Let's suppose I'll start making them from today onwards. So
Yeah.
I'll let you know. Actually, my son is also giving the O level papers, so that's why I'm
Oh,
very busy with him.
well,
So
how old is he?
he is, mashallah, he is 16 now.
16. Ah, so like GCSEs here. Ah, I
Yeah,
see.
yeah,
Yeah,
GCSE, yes.
nice.
Yeah. So
Nice. I
that's
wish
it.
him the best.
Sorry.
I wish him the best. Good luck.
Thank you. Thank you so much, Maya.
With a mother and a teacher like you know, I'm sure he's gonna do well. Yeah.
But it's very difficult to make the
Yeah.
boys sit. Uh,
Ah,
the,
yeah. I'm sure
they
my mom is also experiencing the same thing. She's always telling me, Mahi, sit down.
Oh, really? My daughter was a nerd actually when she was a student. She's a student, but when she was doing GCSE and A levels, she used to study a lot.
Mm,
So now she's a bit relaxed.
yeah.
The course content is very easy because she has opted for BSIT. So that's an entirely different field, not very
Mm,
very gross or very um, in detail, not in
yeah.
great detail. All right, Maya, let's start the lesson now.
Yes.
All right. So,
I think we were on question 12
okay.
of the multiple choice questions.
Yeah.
Hmm.
Have you gone through this?
No,
The
I
whole
haven't.
document.
I
No?
wanted. Sorry, what?
Have you gone through this whole document?
Oh no, I haven't because I wanted to look at it fresh.
Okay. Okay.
So
So,
I didn't do it.
Maya, we can opt for one more approach. If you think that the question is easy and you can do it on your own, we can move on to
Yeah.
the next question if you want, right?
Okay.
So that we will continue. So we will do only those questions which are hard or tough for you.
Yeah. Okay.
So what about question number 12? I taught you this in great detail.
Yeah. This is just balancing equations, right?
Yeah, yeah.
Okay. So first, I'm assuming you have to look at the charge. Sorry.
Mm.
Uh,
Uh, well, oxidation
Oxidation.
number.
Yes.
Yeah,
Of manganese.
yeah. First, you need to look at the oxidation numbers. Then you need to do the balance for electrons, then balance for charge, then balance for hydrogens, and then check for oxygen.
So it goes from +7 to +2.
Yep.
So there must be 5 electrons on the left-hand side.
MnO2. Yeah, plus 4 to plus
Is it?
7.
Is it?
MnO4, KMnO4. Yeah. So plus 7
Yeah.
and then plus 4. Yeah.
Plus 4.
Hmm. MnO2. Have a look. This is
Oh
minus
yes,
2.
yes, yes,
Minus
yes.
2 times 2 minus 4. And then it
Yeah,
will be balanced by plus 4.
yeah. Sorry, that was
It's
my
okay.
signal.
It's okay.
Um,
So that means 3 electrons.
3 electrons on the left-hand side, right?
Yep.
Yeah.
So
Okay.
MnO4 negative plus 3 electrons changes into MnO2. And by the way, they have mentioned that you need to use hydroxide ion, although they have been again balanced with water. So you need to add hydroxide ion towards the right side of the equation. Yeah.
Okay. Yeah.
So first you used to balance, if you remember, Mahia, you used to balance with XH positive, yeah?
Yeah.
And
Yeah.
in this case, you will balance it with XOH negative.
I see. Okay.
Got it?
Yeah.
So is it possible that if you give it a try yourself?
Yep.
All
I'll
right.
do that.
All right.
And
Yeah. And then you need to do it for iodine. Don't forget to, because hold on, Mahia, hold on. Let me tell you, this is a redox equation. If you have a
Yeah.
look, why? Because it contains an oxidizing agent and a reducing agent. Yeah.
Yeah.
So if you remember, I told you for a full balanced equation. Do you remember I told you about the full balanced equation? That first you are going to do everything with one equation, and then you will write another equation underneath it, and then you will cancel the electrons, and then you will write the full equation. So
Yeah.
this is actually the full equation. Are you getting my point?
Yeah.
All right.
Yeah.
So you need to do it in this way.
Um,
Do you want to do it now, or you want to try it afterwards?
do it now.
Okay, fine. Sure.
So then, after the electrons, you look at the overall charge, right?
Yes.
So MnO4 minus, that's 1, and then 3 electrons, so minus 4.
Three electrons. Yeah. So you are going to write what? First, you will write oh, sorry. You will write MnO4 negative plus 3 electrons changes into MnO2. All right.
Yeah. And then plus 4 OH minus
Plus 4 OH minus. Well done. And then it
yeah,
will be balanced by two waters.
on the other side. Yes.
Yeah. Is it clear?
Yeah.
And now
So
do
then
it for iodine.
3 minus plus
Iodine changes into IO negative.
uh okay, I minus 2, I
Yes.
O minus. Okay. So plus 3.
Plus 3. Check again. Wouldn't it be
Sorry,
plus
sorry, so,
2?
so minus 1 to plus 3.
How come, Maya? This is minus 1. Yeah.
Yeah.
So this is what? X plus minus 2 is equal to minus 1.
Oh, my God, Miss Shabnam, oh,
It's okay. So X is equal to minus 1 plus 2. So X is equal to
minus plus 1 plus 1.
plus 1. Just a minute. X minus 2. Yeah, so X minus 1 minus 2. So X minus 1 plus 2, X is equal to plus 1. If we do it the other way, that is IO negative. So, okay, fine. So we need to go, all right, we need to go from minus 1 to plus 1. So that is minus 1 to 0 and then plus 1. So how many electrons need to be added? Plus 2. Are you getting my point?
On the right-hand
Right
side, right?
side, yes.
Yeah.
Are you getting it, Maya?
Yeah.
Good. So let me rub this out. So I'll write plus 2 electron here, and then plus XaOH negative here. Yeah. So how
Plus
would it?
plus plus 2 OH.
Yes, excellent work. Plus 2 OH negative. And
And
then
on
how
the
many
other
waters?
side, we have 2, sorry, one
One
H2O.
water. Yeah. Is it clear?
Yeah. And then
Good.
you multiply
Now
by
we
2.
have, yeah, 2 electrons here and 3 electrons here, prime numbers. So what we
Yeah.
need to do,
Uh,
multiply it by,
2 and the bottom by 3.
there you are, and the bottom by 3. So
Yeah.
you are going to get, wow, great, lots of calculations only for 1 mark.
I know, I know. That's the problem with multiple choice. They always do that.
Yeah. Yeah. So this
Like,
would be 4H2O. I'm doing it the first one, right? 4H2O plus 2MnO4 negative plus 6 electrons changing into 2MnO2 plus 8OH negative. Are you following, Maya?
yeah,
Yes, good. The next one is multiplied by 3. So I'm going to get 3I negative plus 6OH negative arrow, 3IO negative plus 3H2O plus 6 electrons. So that would be 6 electron would be cancelled by 6 electron, and then 6 OH negative would be cancelled by 8. That would be 2 OH negative would be left. Now, the next thing is 3 water molecule whole will be cancelled by this, and we will be left with 1 water molecule. All right, is it
yeah,
clear?
yeah.
All right, good. So
But
I'm going.
do you have to cancel the water molecules as well?
I have to, Maya, because there are 4 water molecules on the left side of the equation and 3 water molecules towards the right side of the equation.
I
I
see.
So you have to cancel left and right. If you are picking something from left, right, then you have to cancel it with left.
Okay, because I think I was only told that you had to cancel the electrons. That's it in school.
Yeah, you have to cancel the electrons because most of the time what we do is we write water and hydroxide with only one equation. But the
Yeah,
equation given in your exam is actually having both the things. For example, MnO2 and then the oxidizing agent and reducing agent, both the things.
yeah,
Oxidizing and reducing. So that's why you have to apply water and hydroxide ion with both the equations.
yeah. Okay.
All right. So now we are left with only 1 water molecule is left and 3 iodide. I'll write water at the last. So 3I negative plus 2MnO4 negative plus water, 1 water molecule changes. If I will write iodide first, then I'm going to write 3IO negative first. After that, I wrote MnO4, so I will write 2MnO2, and in the end, I will write 2OH negative. So this is our final equation. Now, what are they asking for? They are asking what is the ratio of MnO2 and OH negative in the balanced equation. So we have already made the balanced equation. Now, what is the ratio of MnO2 here and OH negative here? So that is 2 ratio 2, and 2
Yeah,
ratio 2 means 1 ratio 1. So the option
yeah.
would be
See.
C. C. Are you getting it, Maya?
Yes. Yeah.
Any confusion, beta?
No.
All right, good. Now the next one. Which statements are correct when a catalyst is added to a system in dynamic equilibrium? The rate of the forward reaction and reverse reaction increases by the same amount. So they are asking you that what is going to happen when you are
Yeah.
going to, when a catalyst is added. So that is the main keyword. Catalyst is
One
added.
one is definitely correct
Definitely correct. Definitely
because
yes.
catalyst only changes the increases the rate.
The concentration
Um,
of reactant and product do not change.
that's true. They
That's
remain
true.
constant.
Yes. The value of Kc increases.
Kc is equilibrium constant.
Yeah.
No, I don't think so. It
Well
remains
done.
constant
It is only affected by what? It is
by
only,
temperature, right?
yep. It is only affected by temperature. So that is the only affected by temperature. It is not, Kc is not affected by initial or final concentration of
Yeah.
the reactant, initial and final concentration of the product, the rate of the forward, the rate of the backward reaction. It doesn't get changed. So it only changes when the temperature changes.
Michelle, I just want to confirm a couple of things. Um,
Mhm.
so the value of Kc remains constant. Is that because if both the rate of the forward and the backwards reaction increase by the same amount, they're
Yeah.
going to cancel out anyways
Yes.
to whatever it was.
Yes.
Okay. And second thing is, um, Kc is only affected by temperature.
Yes.
Um, Like what? Why can? Why is
Yeah.
that?
Yeah, this is because when you increase the temperature, the kinetic energy of the molecule increases. So
Okay,
there would be
it's
more
about
successful collision.
yeah.
So,
Okay,
yeah, got it?
okay, yeah. I just wanted to check that it was about collisions and kinetic energy.
Yeah,
Okay.
yes, yes, yes. Should we go on to the next? Oh, so the answer would be B.
B. Yeah.
Next question. Which statement for group 2 elements is correct? The second ionization energy of magnesium is greater than the second ionization energy of calcium. All right. So first of all, we need to um, because why did I start straight away? Because they are asking for the correct equation. So we need to look at the correct equation, right? So
Yeah.
calcium, we need to look into magnesium and calcium and keep this thing in mind that second ionization energy. In the
Yeah.
data booklet, the ionization energies are given?
No.
No. All
They
right.
only give the periodic table. That's it.
Oh, really? Okay.
Yeah. They don't
So
give us ionization energy.
okay, so in our boat they give first, second, third, fourth ionization energy,
Oh
and then they
wow.
yeah, and then they ask the questions related to it, which is quite difficult for the students to judge. All right, so
Oh,
that is beryllium, magnesium, calcium, strontium, barium. You know what, Maya? I always think that by the grace of God, I am able to teach IB, AQA, OCR,
yeah.
WJEC, honors chemistry, sophomore very easily. So
Yeah.
I one day I was just sitting and I was thinking or analyzing myself that what made it easy for me, that how can I teach all the boards sorry, I forgot about edexcel. So I was just thinking that which is the factor which is making it easy for me to comprehend all the boards with great ease or with a great expertise. Then I came to know my CAI board,
Yeah. Wow.
which is the most difficult board. And it is on the top of the list. So yeah, that's because all the rest of the boards, they have the syllabus which is one tier down the
Yeah.
rest of the syllabus. So that's why it is easy for me to comprehend each and every syllabus. Otherwise, there is a great variations in the board. All right.
Yeah.
So, sorry. So, beryllium, magnesium, calcium, strontium, and barium. So, if you have a look, you will come to know that this is magnesium and this is calcium beta, right? So,
Yeah.
second ionization energy of magnesium is greater than the second ionization energy of calcium. You know that as we go down, the group atomic radius increases. Yeah. So that means that the atomic radius of calcium is greater than the atomic radius of magnesium. So it is easy to draw out the electron from calcium as compared to magnesium. So definitely, even if we talk in terms of a second ionization energy, as you know that the charge on all the atoms would be +2. So this is nullified. So we are not going to talk in terms of charge because charge remains the same. Each and every atom contains 2 electrons in the last shell. So the only thing which is changing is the radius, right? You can
Yeah.
talk in terms of atomic radius or ionic radius. So atomic radius or ionic radius of magnesium is greater than the atomic or ionic radius of calcium. So that is why the second ionization energy of magnesium is greater than the second ionization energy of calcium. Does it make sense?
Yes.
Good. So this is correct.
So
Next.
one.
Yeah.
Yeah.
One is correct. So next, a strontium ion, Sr2 positive, contains a total of 6 electrons in the s orbital. So we need to work out the yeah, electronic
Electron.
configuration.
Yeah.
So strontium. So can you tell me what's the atomic number for
Uh,
strontium?
Miss Shannon, can you tell me the nu- the number of electrons it has? I haven't got my periodic hang on. I have it.
Okay. Okay, let
No,
me.
it's okay, Miss Shannon. I have it. I have it.
All right, fine.
Um, 38. Okay.
38. Okay. It's
Yeah.
38. I remember most of the atomic number, but honestly, I didn't remember the strontium one. So,
Yeah.
It's easy for doing it for beryllium, magnesium, and calcium. That's it. After that, I don't remember. Calcium is 20, 40. Strontium is 38. All right. So 1s2. Do it with me, Maya.
Yeah.
1s2, 2s2,
Three,
2p6,
yeah.
2p6, 3s2,
That's two, three,
3p6,
yeah,
then 4s2,
yeah.
then 3d10, then
Four
four
P,
P6, and then 5s2. Count them up.
2, 4, 10, 12, 18, 20, 30. Yeah, that's correct.
All right, good. So the strontium plus 2 ion. So what should it be? Plus 2 ion means I need to remove these two electrons.
Yeah.
Yeah. Okay. So a strontium ion contains a total of 6 electrons in s orbital. So let me highlight the s orbitals. This is the s orbital, and this is the s orbital. Yeah, and this is the s orbital. So count them up. This is 2, this is 2, 4, and
The 2s2.
2s2. Yes, 2s2. Yes. So this would be, thank you. So this would be 2, 4, 6, and 8, total 8. And yeah,
Yeah,
a strontium ion contains a total of 6
that,
electrons in s
that's
orbital.
correct.
Yeah, so ion. So this 2, 4, 6, 8. And this is the total, and this would be
Removed. So it must.
removed. Yes. So 2, 4, 6. Yes, it's correct, right?
So you can cancel C and D immediately.
Hmm.
Um,
Yes. Yes. Clear? So your answer should be between two options.
yeah, A and B.
Yeah.
Three is definitely wrong. It has to be wrong.
Hmm. But then we don't have any option. Oh, all right. One and two. Is
One
it
and
clear?
two. Yeah.
Yeah. Yes.
The equation, surely it should be BA brackets OH2.
Yeah. So this would be Ba plus H2O changes to BaOH twice plus hydrogen gas. In order to balance it, I need to put 2 here.
Yeah, okay.
Is it clear?
Yeah.
All right. Should we go to the next one then?
Um, just sorry, just 1 second, Miss Shipman. Just so the answer is B,
I am
right?
sorry. I am sorry. Just a minute, Maya. Hold on, hold on. We forgot about 1 is 2. So this should
Oh,
also be included. Yeah. So this would be 2, 2, 4, 6, 8, and 10. So if this 5s2 would be removed, then there must be 8 electrons.
oh, Miss Shabnam, I can't believe you noticed that. Thank you very much.
Yeah, yes, 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 yes.
So two, so the answer is D. Oh my,
Yeah,
wow.
the answer is D. My
So
bad.
it just completely cut out all the other ones. Wow.
Yeah, my bad. Luckily, I was able to see it. I was like, there was something nagging behind my mind that there is something missing, and I was just
Yeah,
looking at this question.
I could sense your hesitation. You were like, oh, yeah, are you sure? Yeah,
Yeah.
but,
So
yeah.
this was
Thank
2,
you.
4. Welcome. So this is 2, 4, 6, 8, 10. And then when these two would be removed, we are left with 8. And they
Yeah,
have written 6 here. So the answer is, oh, now I have to change this.
just,
The answer is D.
just, yeah,
Yeah. Okay. Perfect. Good. Well done. Good question. Got
yeah.
got many loopholes. All right. Okay. Which statement for the complex ion is correct? Which statement for the complex ion is correct? Okay, so let's make it out.
CO. Um,
CO, then like this.
surely all isomers have optical isomerism. Sorry, all complex ions.
Yeah, this is a transition metal complex.
Yeah.
So this, and then this, and then we have
Oh,
NH2.
Miss Shubnam, quick
Yes.
question. What
Yep.
does it mean if it has six-fold coordination?
Six coordination number. What do you mean by this?
No, it says it.
6 4. Okay, fine.
Yeah.
6 4. I'm going to discuss it. Let me just make it,
Okay.
then I'll tell you,
Yeah.
right? Okay. So this is NH2. The six coordination, six-fold coordination number means coordination number is six.
Okay. Yeah.
Coordination number is six. So count them. One. Okay, let me first complete it. Uh, Let me first write this. NH2, NH2, and NH2, and NH2. And after that, what I need to do is like this, then like this, then like this, like this, and then like this. Okay. Now, yes, what were you asking? Coordination number six. Have a look, Maya.
No,
One,
no, no. It,
two,
it says it says six-fold coordination. Oh, coordination of six. Okay. Okay. I see.
yeah. So
So
one,
that's
two, three, four, five, six. The
so
six-fold coordination means that the coordination number is six.
yeah. That means it's
Okay.
true.
Yeah, it's true. It's correct. So it has cis trans isomers. Definitely, it is going to have. No, it is not going to have six trans isomerism because all the groups are the same. So that would be wrong. Or because why? Because the bidentate ligand is the same. They all are same. Are you
I
getting
see.
it, Maya? Bidentate. By the way, it's a bidentate ligand.
Okay. Wait. Sorry, Miss Sharma, can you explain the first one again? It doesn't have cis trans isomers.
Yeah, Maya cis trans isomerism mean that these ligands should be different somewhat. Cis is when they are opposite to
Yeah.
each other, and sorry, trans is when they are opposite to each other, and cis is when they are parallel to each other. That means
So
one
so
beside the
all the
other.
ligands are the same.
So we don't have cis and trans isomer.
Yeah.
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 So this
So
would
no.
be now. Let me show you how it could be cis isomer or trans isomer. Have a look. Cl and Cl. So this would be cis, or this would be trans. Are you getting my point?
Yeah.
Good. All right. So this is correct. It has optical isomerism. So yeah, it has optical isomerism. Why? Because you can make a mirror image of it.
Yeah. Does I mean does everything have optical isomerism?
If yeah, if it is written in the 3D form, this wedge
Oh,
and dotted line. Yeah.
yeah.
So you can make a mirror image of it actually. Yeah, I can make a mirror image of it.
Yeah.
All right.
So
So
I mean you can well if one is wrong, then you can just cancel them out. So the
yeah.
answer should be
Yeah. So you can,
C.
yes, it's a trick that if you are very sure that first is wrong, then your answer should be two and three
Hmm.
because one is
Hmm.
the part of three options. So
Yeah.
if one is wrong, then you are only left with two and three. Are you
Yeah.
getting my point? No?
Yes. Yes, yes, yes. No, I understand.
Oh, all right. So next is this one. Oh, now structured questions. All
Yes.
right. This question is about magnesium bromine and magnesium bromide. All right. So before starting this, why not to underline this? Magnesium is a metal. Bromine is a non-metal. And magnesium bromide is an ionic compound. Yeah.
Yeah.
This is group 2. This is group 7, and I can't write any group. However, I can write that this is made between group 2 and group 7, so that would be an ionic compound. When something is made between group 1 and group 7, or group 2 or group 7, or group 2 or group 6, or group 2 or group 7, that is an
So
ionic
metal or
compound.
non-metal.
Yeah,
Yeah.
yeah. The bond between metal and non-metal will always be an ionic compound. So explain what is meant by the term weighted mean mass.
It's the average mass. Ah, the average mean mass of an atom compared with.
Mean.
Oh, so the mean.
When do you calculate mean?
When do I
When,
calculate mean?
yeah.
When you're.
You calculate mean, Maya, when there is a very slight difference between the reading. You must have done the titration in the lab.
Isomers or so not isomers,
Isotopes.
isotopes. Yeah.
Yeah. So the mean taking into account the relative abundance of the
I see.
isotopes.
Yeah.
Got it?
Yeah.
Because you take a mean in the titration because the values are very close to each other. Yeah. So you take
Yeah.
the mean titer. Same is the case with the atoms that when they have the isotopes, there is a very slight difference between the number of neutrons. So new isotopes are formed. So that is why we need to take the mean.
Yeah.
Okay, so the mean taken into account the relative, so that's why I have circled mean, relative
Yeah.
abundances of the isotopes. Is it clear?
Yeah.
Did I right?
Yeah.
Yes, so I haven't written the full line. Should I write the full line, Maya?
Um. Yeah. Sure. I don't mind. I mean, oh, you can just tell me. It's okay.
All right,
Oh
the
no no.
mean taking into account the relative abundances of the isotopes. It's of only
Yeah.
1 mark, so this much information
Well,
will be
yeah.
fine.
That's okay. Yeah.
Yeah. So draw a dot and cross diagram of MgBr to ionic compound.
Yeah.
It's very easy. So can you tell me?
Yeah.
One
Yep. I
electron
can
will
do
be
it.
two electrons would be transferred from magnesium to bromine. And
Yep.
because bromine can take up only 1 electron, so you need to have how many bromide ions?
Two.
Two. So can you do it on your own?
Yep. I'm doing it.
All right, good.
5, 7, and then 8.
I'm going to write down the answer. So after doing it, you can check from the screen.
Yep. Sorry.
It's okay.
Yep. Uh.
I have already written ionic bonding here.
Yeah.
Yeah. All right. So next
Yeah.
question. Calculate the total number of ions in 1.74 grams of magnesium bromide. Give your
Yeah.
answer to three is significant because it's very easy. Can you do it?
Yes. I'll do that. 1.74. I need my calculator. That's fine. Um, 20. Sorry, Shannon, I'll just get my calculator.
Sure, sure.
Okay. Well, total number of ions. Okay. Mr. Lim, is the answer 1.71 times 10 to the 22?
Yes, well done.
Okay.
Good, well done. Shabash. All right, this one. Table 16.1 shows some physical properties of magnesium bromine and magnesium bromide. Substances are given, their melting points are given, the electrical conductivity is given, right? Now you can see that the melting point of magnesium is the highest, all
Yeah.
right? And then comes magnesium bromide, and then bromine is the least, right? Now,
Yeah.
electrical conductivity, because magnesium bromide in solid it is not going to conduct the electricity, and definitely in a liquid in aqueous form it is going to conduct the electricity, right? However,
Yeah.
bromine, both in both the column solid and liquid, we are getting poor because bromine is a non-metal, right? So it's
Yeah.
neither an ionic compound nor it's a metal, so definitely there would be poor in both the columns. Now, when we come to the metal, then we are having good, yes, because it has metallic bonding. So the answer is here, that is magnesium. It has the highest melting point because there would be a strong attraction between the metallic cations and the sea of delocalized electron. Yeah, and that would have a giant lattice. And then comes
Yeah.
bromine. Bromine is because bromine is a simple molecular ion, and the only forces which is present between Br2 would be the weak intermolecular forces, that is dipole-dipole
Mm.
interaction. Yeah, rather induced dipole, temporary dipole and induced dipole, because there is no difference in electronegativity as both the atoms are the same. Are you getting
Okay.
my
Yeah.
point, Maya?
Yeah. Sorry,
And
so, Mr. Blum, what structure is magnesium?
magnesium has giant lattice, metallic
Is it
bonding.
giant metallic lattice?
Yes.
Okay.
And bromine has simple molecular structure.
Yep. And then magnesium bromide is giant ionic.
Yes, it has giant ionic lattice. And then
So,
you need to relate the melting point with the type of attraction present. So magnesium has the highest because there is a attraction between the metal cation and the sea of delocalized electron.
but Mr. Blum, could you say that? Would you say that metallic bonding is stronger than ionic bonding?
Actually, you know what? It depends. If you will compare it with sodium, then no, because sodium has a charge of +1. But when you compare magnesium, so you have a charge of +2. So that is a strong bonding. Even if you
Uh,
go to aluminium, that would be the even strongest. So you cannot make a hard and fast rule that metallic bonding is stronger than ionic compound. This is completely wrong. Yeah,
okay.
but it depends which type of metal is given to us.
Yeah.
All right. So if you are going to, let's suppose, if you are going to have sodium, then the metallic bonding in sodium is definitely weaker than the ionic bonding in sodium chloride.
Yeah.
All right. I hope it makes sense.
Yes.
However, you can say that metallic and ionic bonds are stronger than the covalent bonds, which is
Yes.
in case of which are present in case of bromine, right? So they are saying that explain the physical properties shown in table 16.1 using your knowledge of structure and bonding. So that means, now let me highlight the keyword structure and
And
bonding.
yeah,
Is it clear?
yeah.
Good. Should I write the answer or is it all
Uh,
clear?
no, it's okay. It's all clear.
All right. Okay, let's go to the next question. Oh, wow. Born-Haber cycle. Yeah, Born-Haber. Yes, Born-Haber cycle. Now, can you fill in the missing information?
Yes.
An
Um,
incomplete energy cycle on table 6.2 is shown below on the dotted line and the species present, including space state symbols.
yeah.
So do tell me. And then I think you will be asked, because the data is given, so definitely you will be asked to calculate the lattice energy.
At
Mm.
the species
Yeah,
present.
hydration.
Okay.
They have asked for the hydration. Okay, fine.
Yeah.
Good question.
Okay, I'm just trying to label everything quickly.
Yeah, sure. Take your time. Maya, you have unit 1, 2, 4, and 5?
Um, if you can tell me the names, I'd probably know better.
No, do you have 5 papers or 4 papers?
We have three papers, Miss Shubnam.
Oh, 3 papers. Okay,
So,
fine.
so yeah, okay. Paper one is just physical. Paper two is just organic. Paper three is unified.
Okay. Paper 3 is unified.
Yeah.
Okay. And yours is chemistry A
OCRA. Yes.
or CRA. Yeah.
Yeah. Hydration of magnesium -9. Okay.
Mhm.
Mission is the answer. 1561.5.
This is what Maya hydration energy
Of bromide ions.
of bromide ions. I could, just a minute, let me calculate. Maya, in this, you simply need to write down the equations.
Oh,
Here,
sorry, sorry. Yeah, I did that. So for the first, so the top box,
top
I wrote
box.
Mg2 plus gas
Yeah,
plus 2 Br gas plus 2 E minus,
there you are. Well done.
and then for the bottom one, I wrote Mg solid
Hmm.
plus 2 Br solid.
Mg solid plus 2Br solid. No, Maya, this is formation. So you need to write in their standard, most stable standard state. This is formation. This is enthalpy of formation. You need to form MgBr2 solid. So this is standard enthalpy change of formation. And in formation, we take the elements in their most stable state. So the stable state for bromine is
Also, it'd be
Br2.
Br2 my
Yeah,
gas. Ah,
it's
I see.
liquid.
Yeah.
It's liquid.
Oh, liquid. Okay.
Yeah. Is it clear?
Yeah.
And this one, by the way, just for your information, this is what? This is the second ionization energy. Yeah.
Which
And this would from Mg plus 1 to Mg
it's the
plus 2.
second. Second.
Yes,
Yeah.
second ionization energy. And this one would be the electron affinity.
Yeah.
Okay. Now, yes, you were giving me the answer for what?
Hydration of bromide ion.
Hydration of bromide ion. What was the value?
I got 1561.5.
1561.5. No, I have calculated it differently. Let me check. Let me write it. That would be, so this would be, the first one is minus 525. That would be minus 525. The other one would be 112 times 2. So this would be 2 Br. 2 Br. So that means 112 times 2. Okay. The other one is 148. 148 plus the other one is 736 plus 736. And then this one is 1000. What? 1450 plus 1450. This would be minus 325 times 2. And this would be magnesium ion minus 1926. And this would be hydrogen or bromide and delta H is equal to question mark. Okay. So now Lagrange minus, sorry, 1, 2, 9, 6.
Never mind, Mr. Ovnum. I think I got it wrong. I definitely got it wrong.
Yeah. mm. Let me calculate it on the calculator. So this
Yeah.
would be, yes, this is minus 346.5 kilojoule per
Okay.
mole. This is the answer.
I need
Where
just
did,
to redo it. Um,
yeah, this would be. Okay, let me check again. Okay, let's choose 14, 2, 2, 2, 4. Yes, let me check again. I'm just checking. 3, 2, 2, 2 times 2. Hmm. Yes, Mahia, are you able to get the answer?
I don't know. I think I'm. Look, I've written the orders down correctly, the numbers down.
Hmm.
But I just don't know what I'm doing to. I just don't know how to well add them up in the way that gets me the answer.
You can do, you know what you can do is this is equal to the sum of all these.
The formation.
Huh. Yes, the formation is equal to the
Oh,
sum of all these.
I
First do
see.
it.
And what about the enthalpy of solution?
Enthalpy of, so whatever is given here, Mahia, this is
The
what
minus one
enthalpy
eight.
minus the solution of magnesium bromide. This is given minus 186.
Yep.
Yeah.
It's because you didn't write it, so I wasn't sure if
Where are you going to fit it in? Where you know what? One nine
Michelle,
one nine. Yeah.
it's below the minus 525
Yeah.
in the cycle.
Yes, yes.
Yep. So do you include that?
Yes, you are going to include this, but this is actually you are going to say formation is equal to this the sum of all these, and then after calculating it, then you are going to add this one. So in if you are going to write, or there is another way in which you can do it. That is 1926, and then plus this the same thing plus this plus this and then this and then this and then this and then this one and the same thing, and then whatever would be the answer, because this is 2 bromidine, so in order to calculate for 1 you need to divide it by 2. This is another
Yeah.
way. You can do it in this way as well, whatever is easier for you.
Okay. I'll
Yeah.
do that now.
Okay. Now, but keep this thing in mind, Mahia. If you are going to opt for the second method, keep this thing in mind that you need to change the signs. So this is if minus 1926, that you will take plus. If this is minus, they will take plus, and this would get minus. This would get minus, 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 and then this would up till here. All right. And after that, these two are downward arrows. Then you need to keep them like this: minus 525 and then minus 186. So keep this
Yeah.
thing in your mind. These are upward arrows. So you need to change the signs. But this is a downward arrow, so you will keep the sign same. Okay?
Yes. Okay. Minus 55 plus 2, 4.
I was doing
Uh,
it differently, but you will get the same answer in both the ways.
yeah. Got it. Okay. Miss Shubnam?
Yep.
Uh, okay.
What are you getting?
Uh, I'm,
Should I write it then?
yeah, yes, please, Miss Shubnam, but I
Yeah.
really don't know what I'm doing
Oh,
wrong.
it's okay. It's okay. No problem. So I'm going to do it this way, right? So I'll change the sign. It would become 1926.
Wait,
And then,
Miss Shubnam, may you do the first way instead? Is that okay?
yeah, we'll do that.
Okay.
Okay. Then that would be, then you simply need to add them up. Can you do it on the calculator then? So
Yeah.
that would be 12 into 2, that is 224. 224 plus 148 plus 736 plus 1450 is equal to 2588. Just so that would be, so that is plus plus 2558, and then this would 355 times 2, that is minus 650, and this would be minus 1926, and that is the calculation. So that would be 2558 minus 650 is equal to this. So, and then minus 0. Just a minute, Maya.
Yeah.
2558. Because I'm doing it the other way around. Just give me a little time. 1908 plus then 1126 minus 1108. That is 18. That is 18. Now then comes plus x is equal to minus 525 minus 186. So that would be equal to 525 plus 186. That is plus 711, and then plus 711 minus 18. That would be 693. Plus or minus 18. That would be 693. Minus 19. That would be plus 7 or plus minus 525 minus 186. That would be minus 711. Just a minute. 525 plus 186. Yes. So that would be minus 711, and then minus 711 plus 1. I have to subtract 711 minus 18. That would be minus 693. Now minus 693 divided by 2, that would be 693 divided by 2, that would be 346.5. I have calculated in the other way. Yes, the same answer. All right. Yes, Maya, what you need to do is add them up. Keep now I will do the other way around, right?
But wait,
So
sorry, which ones do I add up in what order? In what
I'm leaving this, Maya. Look, I'm leaving this, beta, and I'm
Okay.
starting from here.
I
So,
see.
so that would be 112 times 2 plus 148 plus 736 plus 1450. Are you following this?
Yeah,
Uh,
148
this.
plus.
Yes, Maya?
Yeah.
So this all makes up plus 2558. Please check.
Okay, I'll plus 2 times 1 and 2 plus 736 plus 1550. 2558.
Yes, same answer, right? Can
Yeah,
you see? All right.
yeah.
Now these two values, this, and this. So write plus minus 325 times 2 plus minus 1926 plus x. So now add them up. 325 times 2 is minus 650. So plus 2558 minus 650 and minus 1926. Now add them up, right? So what it would be? 255 minus 650 and minus 1926. Add them up. This would be 650. This would be 2576. Oh, no, this would be plus 2558 minus 650 minus 1926. Is it clear? Plus x.
Yeah, I got 18.
18, yes. So it would be minus 18,
Yeah, minus 18
minus 18 plus x
plus x. Yeah.
is equal to, let me wrap this, it would be minus 525 and minus 186. Yes? These two. These
Yeah,
two.
minus 525 minus 186 is equal to minus 18 plus
No,
x.
yes, is equal to minus 18 plus x. Yes?
Yeah.
So I have already written it. Minus 18 plus x. Now add them up. So what would be the answer? Minus 525 minus 186.
Minus 711.
Minus 11 is equal to minus 18 plus x. Bring this to the other
Yeah.
side. Minus 18 to the other side. It would become
So,
positive.
uh, no.
Why?
Oh, the
Manya, you are.
18 will
Yes.
become positive. Oh, but the overall answer is
Yes.
still minus
No,
693
no, no. Minus 711 plus 18 is
plus,
equal to x. Yeah.
yeah,
And then
yeah,
it would be seven. This is minus 693
yeah,
is equal to x.
yeah. And then
Yeah.
divide that by
Now
2.
check. Yes, you need to divide it by 2. 693 divided by 2 minus 693. What is the answer?
I got minus 346.5.
Yes, this is the answer.
I see.
Is it clear?
Yeah. Okay. I just didn't really know what order I had to go around in, right?
Should I tell again that which order I have selected?
No, 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 that's okay. I think I've got it now.
Yeah?
Yeah.
All right. Okay,
Okay.
fine. Good.
Thank you very
So,
much, Miss.
you're
Thank you.
welcome. You're welcome. Maya, if you get time, try to complete this paper.
Yeah, okay. Yeah,
If
I'll
you
do
get
it.
time,
Yeah,
right?
I'll do it.
It will give you a very clear idea.
Yeah.
Okay? All right, fine. And the other thing is, next time we are going to do the organic chemistry, right?
Yes, the pathways. And
Oh, yes, the
yes.
pathways. All
Okay.
right. Okay,
Yes,
thank
thank you very
you.
much, Miss. Have a
No,
nice weekend and a good week ahead.
thank you.
And
Same
take care.
wishes for you. Take care. Bye
Thank you.
bye.